Electric charge is a conserved property of matter that influences interactions between atoms. Charged matter can be either positively charged or negatively charged, or it can be neutral with no net charge. In this lab experiment, we will create a charged object and observe its interaction with other matter. We will then use the laws of conservation, electric force, and electric field to calculate the induced charge. The electric force law describes the force of a charged particle, the surroundings, on a charged particle that we are observing, the system. The charged particle of the surroundings creates an electric field which acts on the observed particle of the system. The electric field is derived from the electric force law. In part 1, we checked that the strand of tape contained a charge by waving our hand in front of it, which is neutral matter. We observed that the tape was attracted to our hand. We determined if the strand of tape was positively charged by bringing a negatively charged marker close to the charged strand. It was noted that the tape was attracted to the marker, which means that the charge of the tape is positive. In part 2 of the experiment, the tapes were set up according to the photo. The second strand of tape was brought closely to the first tape. Doing this, the positive charge of the tape strands repelled each other with enough force to oppose the gravitational force. The distance between the two strands was measured. What assumptions, approximations, or idealizations did I make to find the amount of charge of one tape? The first one was that each tape has the same charge. This is reasonable because both tapes are the same length and underwent the same method to charge them. Next, we treated the tape as if they were a single point charge. This is useful because the measured distance is where the forces repel the greatest. It also made it easier to calculate the unknown charge. We assumed that the magnitude of the electric force was equal to the magnitude of the force of gravity. What was the magnitude of the charge on one piece of tape calculated by computational model? To solve the magnitude of the charge, the first thing we did was that the magnitude of the electric force must be equal to or greater than the force of gravity. We assume that the forces are equal because the charges are the same. Using the formulas, we solved for the charge Q. Using the computational model, we found that the magnitude of the charge of the piece of tape is 7.1 times 10 to the negative 7. Here's my code that I use in the computational modeling. The first thing that I did was establish the constants and also insert the measurements that we found during lab, including the distance between the two tapes, the length, and the mass. Next, I found the force of gravity on the tape, and I used the equation to find the charge from the previous slide. In this experiment, we created charges in matter and observed interactions between the charged matter and other matter to determine if the charge is positive or negative. We studied the interaction of two pieces of tape with the same but unknown charge to solve for the magnitude of the charge using Newton's second law and electric force law. The basic properties of electric forces were clearly displayed in this lab, such as the interaction between like and unlike charges. This experiment can also test other variables such as the effect of tape of various lengths on how the distance between the tapes may change in response to a different length.